Visualizing ML model performance. For example, confusion matrix and ROC curves. Welcome back to Python for AI and Machine Learning. I'm Dr. Azad Rasul, and in this lecture, we are exploring how to visualize machine learning model performance using tools like confusion matrix and ROC curves. They help us understand how will our model work and where they need improvement. Today, you will train a simple model on crop health CSV dataset and visualize its performance to see how accurately it predicts healthy versus unhealthy crops. You'll learn to create a confusion matrix and ROC curve using Python libraries like scikit-learn and matplotlib. By the end, you will be ready to assess models for projects. Let's get started. Manage runtime. It's already GPU. And this is our data, crop health CSV. If it's not available there, we upload to session storage. Let's start by loading our crop health CSV dataset and training a simple model to evaluate. This dataset has 1000 rows with NDVI soil moisture and health column. Here's the setup code. Import pandas as PD, import numpy as NP from scikit-learn model. Import train test split. And from scikit-learn.ensemble, import Random Forest Classifier. Then load and clean dataset, df, data frame equal, pdpanda.readcsv. From content, the file is crop health CSV. Fill NA of NDVI using also mean method. Then change upper value to 1 and lower value to -1. Changing the type of health value from healthy to 1 and unhealthy to 0. After that, split feature and label x equal from data frame, use NDVI and soil moisture values, and for y from data frame, health values 0 and 1. After that, split our data into train and test sets, 0.2, 20%, and random state equal 42 to use the same data and get the same result when we run it again. Train a random forest model equal random forest classifier with the random state 42, model.fit, x train and y train, then predict on test set, y predict equal model.predict using x test. This code loads the CSV and clean it by filling missing values, clipping NDVI outliers, and converting labels. We split the data into 80% training and 20% testing sets. Then train random forest classifier, a simple yet powerful model. The yPred variable holds predictions for the test set. Now let's visualize its performance. We run it. Creating a confusion matrix. First, let's create a confusion matrix to see how will our model classifies crops as healthy or unhealthy. A confusion matrix shows true positives, true negatives, false positives, and false negatives, telling us where the model gets it right or wrong. Here is the code. From scikit-learn.matrix, import confusion matrix and import Seaborn as import matplotlib.pyplot as plt. Generating confusion matrix, we name it CM equal confusion matrix using ytest and ypredict. After that, print confusion matrix is CM. Then we plot with the Seaborn. Heatmap function is inside Seaborn. The data is CM not equal true FDMD CMap blues, the color, X level predicted, Y level actual, the title confusion matrix for crop health model. Then show the plot using plt.show. This is our confusion matrix figure. For unhealthy, we have 138 unhealthy classified correctly. Just 2 unhealthy classified as healthy. And for healthy values, 56 of them classified as healthy. Just 4 values classified as unhealthy mistakenly. Let's explain confusion matrix. We have 138 true negatives. 138 crops were correctly predicted as unhealthy, which is actual is 0 and predicted as 0 value. And we have 56 true positives. 56 crops were correctly predicted as healthy. The actual was 1 and predicted as 1. 2 false positives. 2 unhealthy crops were wrongly predicted as healthy. And 4 false negatives. 4 healthy crops were wrongly predicted as unhealthy. This matrix shows great performance, only 6 errors out of 200 predictions, giving an accuracy of 97%. 138 plus 55 divided by 200. However, those 4 false negatives are concerning for farmers, as missing unhealthy crops could impact yields. The Seaborn.heatmap plots this as a 2 by 2 grid with the members in each cell, making it easy to spot errors. Try running this to see your model's matrix. Plotting an ROC curve. Next, let's plot an ROC curve to measure how well our model distinguishes healthy from unhealthy crops. The ROC curve plots true positive rate against false positive rate. And the area under the curve, or AUC, tells us how good the model is. Closer to 1 is better. Here is the code. From the scikit-learn.matrix, import ROC curve and AUC. Get prediction probabilities. Y probe equal model.predict probe. using X-test. Compute ROC curve and AUC, FPR, TPR equal ROC curve using Y-test and Y-probe. ROC AUC equal AUC using FPR and TPR. Then plot ROC curve, PLT plot using FPR and TPR, PLT.plot O and 1, XLab false positive rate and YLab true positive rate. The title ROC curve for crop health model and the legend location lower right side. Then show the plot. Let's run the code. The predict proba method gives probability for the healthy class. The ROC curve function computes false positive rate, FPR, and true positive rate, TPR, and AUC calculates the area. Our output AUC of 1, meaning a perfect model. Very healthy crop is distinguished from unhealthy ones, but an AUC of 1 is suspicious. It might mean the model is overfitting. In real world, crop health predictions, AUCs are typically between 0.85 and 0.95 due to data variability. Try to check your model's AUC. Interpreting visualizations and improving models. Let's interpret the results. The conversion matrix shows 97% accuracy, but the false negative suggests the model might miss some unhealthy crops, critical for farming applications. The AUC of 1 is too perfect, indicating possible overfitting. To address this, check data leakage. Simplify the model. For example, try a logistic regression model to reduce complexity. Or add features. Include more crop health features like temperature to make the task harder and more realistic. These visualizations are vital for crop health predictor, helping you ensure reliable models. Experiment by changing the model or test size to see how it affects the matrix and AUC.